All right, so before we finish this up, there's a few loose ends I wanted to cover, and these are basically other shading techniques. One thing is I want to talk about is light type that you'll come across, light sources or light types that you'll come across in graphics engines, and I think it's worth just quickly talking about them. So the first light type that we have, they're called point source lights. And what that is you have a light and it just radiates equally in all directions. Now, we've already learned about one of these with our Phong model. So to use it, when you do your calculations, all you do is you go, what's my angle from me to the light? Because it's radiating in all directions. So it's really simple. We also have what's called a spotlight. That's a point. I'll be consistent here. We have what's called a spotlight. And it's basically just like the point source light, but it's limited to a smaller area. So we have a point source like this, and it has a center of direction, and then it has an angle within which it's a cone, and within all dimensions, and outside of that you can't see it. Okay, so it's like a point source, but use your dot products to see to see whether you're within that cone or not. Okay, then we have the point source, a spotlight, and what's called a directional light. And my spacing is not working. Okay. And a directional light, what you get are parallel lines, kind of like light coming from the sun, okay? And so the vector from the light source is static, no matter what surface you're on. Okay, so that'll impact how the shading looks, diffuse looks, specular, all of that will impact. Okay, and I can just do a quick demo. I'm not going to go too much into this demo, but I will provide the code, and here's different lights you can play with and turn them on and off. A lot of cool things you can do. So you can move it, and you see I can move it. I have directional light on and off. I have my point light on and off, my spotlight on and off, and so on and so forth. I can change the parameters. I can change all kinds of things. So play with this. It's useful if you want to implement different light sources. It's a good demo that lets you see how they all work. Great. That's all I really wanted to talk about with light sources. All right. So that's it. The other thing I wanted to talk about is that texture memory that we've been using so far to store images, it can be used for other things. You don't need to put an image in there. Texture memory can store basically anything you want it to. Okay, and then you can use that inside your graphics card, inside your program, to do what you want with that information. Okay, not just pictures. Cool. So one thing you can do, for example, you can store transparency. Okay, you can store a transparency map. That's really nice. You can store which parts of the scenes are transparent or not, and you can overlay it on an object in case that object doesn't have the alpha values put into it. You can also put what's called a normal map. And what's really nice about a normal map is you can specify, I'm going to highlight this one, you can specify what the normal is at a pixel without having that built in to the geometry. Okay, so you get the normals at each point. Not each vertice, you can do that if you want to, but each point, because it's like a texture, it's a point based, okay? Each point on the surface. So when you do your texture mapping, instead of grabbing the color from your texel, you grab the normal. X, Y, and R, G, and B could be the directions of your normal, okay? Now remember that normals impact lighting. Right? As the normal changes, the lighting result changes, and you can basically make it look like bumps. Right? And for this reason, it's often called bump mapping. Okay, but I'm going to put a star here. Depending who you ask what book you look into, people will define bump mapping and normal mapping differently. These days, everyone calls it the same thing. In the old days, bump mapping was adding a height value that you could use, but now we're just perturbing the normals, or depending who you talk to. So don't worry too much about the difference between those two. 39 to 41. Let's look at some slides. Okay. So here's an example of bump mapping. We have this nice smooth spherical surface. Here's the texture information. These are normal or height or normal information, in this case height. You can overlay it on the scene to modify how the lighting impacts. And so now this really simple geometry can look really complicated just by putting a bump map on there. Here's another example. This is a more common way to show a normal map. You can, the three channels are visualized in a color space. And look how nice this object looks. Look at the texture you can see. Even though the object doesn't have this texture, this completely comes from the normal map. So this is a very nice way to add a complexity to the scene without adding a lot of complicated geometry. And here's an example that's a little more subtle until you look deeper. Normal maps are used to add shininess, right? You can add shininess to make sure the specular pops out, but it also adds a lot of detail at these little spots where we have ridges. Look how flat it looks on this side. Look how flat it looks over here. Then over here, look how much it doesn't look flat at all. So normal maps can add a lot of rich detail. Look at the gun handle here, all the dots. That's all normal mapping. You can add a lot of rich detail that you don't get. You don't need expensive geometry to do. So normal mapping is really fun. Similar to normal mapping, we have what's called displacement mapping. And instead of using the normal, you can actually use the map to change the physical location of the vertices. Okay. Use texture data to actually move vertices. Again, just like a texture, you can overlay it on an object. You don't need to be built into the geometry. You can overlay it on the object to modify how that object looks. And the results can look really convincing. Look at that. So instead of having complex geometry, again, you have a displacement map. Bam, you throw it on this thing. It changes the geometry right in the graphics card while it's rendering it, and it's a lot more flexible and a lot more... It's a way to modify your object without necessarily having as much memory in there. So displacement maps are a little more complicated to actually get working, but they're really cool. Okay. Now you can do all kinds of things, right? That was slide 42. I guess it doesn't matter. You can do all kinds of things. So I'm going to put other. People have come up with so many exciting and clever and inventive uses for using texture memory and using it for other things. So I just want to make that point clear. It's not just a picture. It's data that you're putting in the graphics card, and you can use it in your rendering. All right. The last thing I want to cover, because it's just so cool, is environment mapping. It's called environment mapping because you're mapping an environment onto an environment texture, an environment onto an object, okay? And sometimes it's called reflection mapping because that's basically what you use it for. And this is a really clever idea. What you do is you simulate reflections. Into a scene, because of course that's really expensive to do properly. And the way that you do it is you modify texture coordinates. Okay? You modify texture coordinates into a texture, oops, that looks like the environment. Okay, so you modify texture coordinates. So I'm just going to draw it. So imagine I have a object that I'm trying to draw. or texture of a triangle. I'm trying to texture. The first thing you do is you draw a box around this, okay? Let's move it down. Why not? So you put a box around it, a 3D box, okay? And on the inside of this box, you draw yourself some kind of scene. Example, an environment, a background, mountains, there's a sun and your mountains continue, and here's some clouds in the background. So you put this thing inside this box, okay? This cube, I should say. And then what you do is you have your camera over here. And when you're going to texture this thing, the goal is you want to use the texture from this environment box to put it onto the object because it's reflection mapping. And this is how clever it is. This is what you do. You take a ray from your camera to the corner, you take a normal and you reflect it, and you calculate, hey, where's that going to be in my environment? You do the same thing for the other one, and it reflects up here like that. And this gives you UV coordinates into your texture space. So what you do is you just map it, you cast 3 rays, bam, you reflect them onto your box, you calculate where they land in the box, you now have your texture coordinates. What's really cool is, if I move my camera over here, I'm going to get I'm going to use a different color. I'm going to get a very different, right? I'm going to get a very different triangle. And so as you move your camera, it looks like you're getting reflections. And this is actually an extremely convincing result. So here's what it looks like. Look at that. So this looks like really complicated. It almost looks ray traced, but it's actually environment mapped. This is the more classic example. Someone goes outside, they take a real picture of a real environment, they build a box out of it, and then it looks really cool. But you really have to see it in motion. Okay, it didn't explode. You really have to see it in motion to believe it. Look at that. How cool is that? And so you can see how that's actually pretty nice to do. The results are extremely convincing. They almost look ray traced. This person's mixing them with translucency and to make it look glass-like. Yeah, environment mapping, you can do water. Really cool effect just by being clever with how you play with texture coordinates. All right, so this is the end. And that's it. That's all I wanted to say about shading.